This video is from Chapter 7, the section called Putting It All Together, and I'll be working through examples 1A through 1G. So here we have 12a squared minus 27b, and the instructions on this were to factor it completely. So this is an expression since there's no equal sign. It's not an equation. So I'm going to look for the greatest common factor. And both of these, well, that's even and that's not, but they're both multiples of 3. So I'm going to pull out a 3, and it's a squared and b squared, so the variables have nothing in common, so I can do that. So that'll leave behind 4a squared minus 9b squared. And as I look at this, I am noticing that 4 is a perfect square and 9 is a perfect square. And we know a squared and b squared are. So then there's no middle term and we're subtracting. So I have something here called the difference of squares. So I know that that will break down into the square root of this minus the square root of that. So the square root of 4 is 2. The square root of a squared is a. Plus the square root of 9 is 3. The square root of b squared is b. Times the same thing minus 3b. So that'll give me 3 factors. 3 and then this factor and this factor. If I wanted to keep going, if it were set to 0, I would set each of these to 0. But as I said before, it's just an expression, so we don't have to go that far. Here we have another expression. It's set up as the basis of a quadratic. The only thing missing again is the equals 0. But I can factor this, and here I have to find, let's see, two numbers that multiply to make 30 whose difference is 1. And even I can do this without setting up a chart. So the first one is y, and the second term, 5 times 6 is 30, and the difference between 5 and 6 is 1. This is negative, so that tells me that it's minus 6 and plus 5. So let's test it. Y times y is y squared. Y times 5 plus 5y minus 6y minus 30. These combine to be minus y, so y squared minus y minus 30. It worked. Okay, and let's go on. This one has, again, it's still an expression. Lots going on here, but there's 4 terms, 1, 2, 3, 4, and that tells me that I should give grouping a try. So let's see. Let's just do this and see what happens. So the common factor between these two terms would be m. So I'm going to take out m and leave behind n squared minus 4. And with this group, the common factor would be positive 5. So I'm going to pull out 5 and leave behind n squared minus 4. And you can see right here that the common factor of the two of them is that. So let's pull that out. N squared minus 4 times m plus 5. Now, you might think you're done, but you're not. Right here, you have a difference of squares. So I am going to play with that. That would be the square root of n minus the square root of 2 times the square root of n plus the square root of 4. I meant square root of 4, sorry. And all of that times m plus 5. So now I have these down to the bare nitty-gritty, so I'm in good shape. Let's take a look at the next one. So here, this is a perfect square and this is a perfect square. So that gives me an idea to give this a try. So I'm looking for perfect squares. So the square root of that would be 8. So I have p. This is positive and this is negative. So that tells me that it's going to be p minus 8 times p minus 8. And I can double check that because this middle term would be 2 times this, and 2 times negative 8 is negative 16. So I could write that more efficiently like this, and I can test it. So negative 8 squared minus 16. Oh, I made a mistake. Don't forget that really, if I were going to test it, p equals positive 8. So 8 squared minus 16 times 8 plus 64. Oh, but I can't check it because I don't have an equal sign. Good save. How would I check that? Well, I could just do this. Let's see, p minus 8, p minus 8. This is another way to multiply these. So negative 8 times negative 8 is positive 64. Negative 8 times p would be negative 8p. And then here I have p times negative 8 would be negative 8p, and p times p would be p squared. I didn't plan very well here. So I end up with p squared minus 16p plus 64. And like I say, that's just another way to do it. No preferences, whatever works for you. Let's see if we can get to the next one. This is 1e, and I have 8x squared, and I think I can whittle this down a little bit. They're all divisible by 2, so I can take out the GCF, and that would be, it's going to be 2 because that's not divisible by 4. So I'll pull out 2, and that'll leave me 4x squared plus 13x plus 5. And this one I'm going to do mechanically. I don't have the intuitive powers to do it. So 4 times 5 is 20. It's positive. This inner sign is positive as well. So both of my factors will be positive. So the factor, I'm looking for factors of 20 that add up to 13. So let's see, 2 and 10, not 3, 4 and 5. So on this one, here's 1e. I can look at this and think, oh, I've got maybe a GCF that I can deal with. So we have a GCF of 2. So if I pull that out, I'll be left with 2x squared, or 4x squared, plus 13x plus 10. So that's a little bit easier to handle. Now, again, I'm going to use mechanics to take care of this. I don't really have the intuitive powers at the moment. So I'm going to look here. 4 times 10 is 40. They're both positive, so this is positive 40. This number is also positive, so that I know both of my factors will be positive. So I'll be combining to find two numbers that add up to 40. So again, let's be systematic. 1 times 40, 2 times 20, no 3, 4 times 10, 5 times 8, 6, 7, 8. Okay, we're ready to start. So we're going to add them up. That's 41. Nope. 22. Nope. 14. Nope. Yay, 13. So over here I have 2 times 4x squared plus 5x plus 8x plus 10. And I know I could have arranged it differently, but it's not going to matter in the end. So here, let's change color because we can. With this group, the thing they have in common is x. So I'll have x times 4x plus 5. And with this group, the thing they have in common is 2. So I'll have 2 times 4x plus 5. And here's a hint. If you're working on these and all of a sudden you notice that this one and this one are different, go back and check, because it's a math book. The chances are good that it's just a mistake on your part. So go back and double check, because most of the time these two factors will be the same. So we have 2 on the outside, and then we have this one and this one. So x plus 2, and then the common factor was 4x plus 5. And there you have it. That is this taken down to its basic factors. And this one has to do with cubes. Okay? And there are patterns with cubes, remember that. So if it's x cubed plus y cubed, that breaks down to the cube root of x cubed plus the cube root of y cubed times x squared plus 2xy plus y squared. I'm sorry, I made a mistake. This should be minus. So the pattern is plus, minus, plus. If it was x cubed minus y cubed, the pattern would be minus, plus, plus. We'll talk more about that if you need to. So anyway, let's take care of this. So we're going to pull out the cube root of this. So that would be 3k, because 3 times 3 times 3 is 27, plus the cube root of 8 is 2, okay, times 3k squared would be 9k, minus 2 times 3 is 6, 6k, plus 4. So those two things together, I didn't leave myself very much room, are the answer to that. And we have one more to go. This is a square, and this is a square. And oh, maybe I could do something with that. But this is a plus, so that means that this is prime. So you can stop. Okay, and copy. And then do the U tries in this chapter.